Okay, so in this proof from the homework this week, you have a clear thing that we want to know and what you want to show. So always, no matter if you're doing a proof for communication or if you're doing a proof just for yourself, always start by writing out what you know and what you want to show. So in this case, we are in a situation where we know that the order of an element in our group has order E, or has order N. And you know what? I said E because I just realized that there's a typo here, right? I have E. A to the power of N is equal to E because it's the least N such that A to the N is equal to E. Okay. And we want to show that if there is a homomorphism, phi from G to H, then the order of phi of A divides the order of A. Now, I want to emphasize, again, we have two different types of proofs. The first one is the type of proof that is behind the scenes, the one that we always start with, where we're just trying to establish how a proof should go. And in it, we're trying to bridge what we know and what we want to show. It's usually a conversation between these two items where we're working our way in between them. Then in our proof for communication, we are trying to give people that bridge, kind of walk them by the hand gently over the bridge and make their journey as smooth as possible. When we do our behind the scenes proof to ourselves, we're often just going back and forth kind of in search of a pathway, right? But when we're leading someone over it, we want to be as smooth as possible. So our starting point might be different in each case. And our argument might be different in each case. Now, all the time, when basically ever you read something, you very, 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 very rarely ever encounter someone's first draft of a proof, the one that they attack first, because it's kind of chaos to see someone else's mindset going back and forth trying to find a pathway. But the polished proof doesn't always tell the whole story either, because you think that people just have a really smooth walk through. And for people who know a subject for a long time, it's really difficult for them to recreate that wild walk back and forth because they kind of know the journey already, right? It's difficult for them to imagine how someone might get lost. It's kind of like if you really know your town really well and you say, okay, well, now get lost here. How would you get lost, right? It would be hard to recreate. So same thing kind of happens in this proof. When I go to write it down, as someone who knows this stuff, you're going to see something pretty straightforward, even when I'm doing it off the cuff. But when you do it, don't be surprised if it's a little bit back and forth, and then it takes a couple drafts for you to get here. Okay, so in this proof, we need to start by making sure we're all clear on our notation. So even though we kind of started off with a to the power of n equal to e least n such that this happens, still kind of nice to just remind people, okay, let the order of a is equal to n. And then instead of using this fact directly, the argument instead may surprise you. It kind of goes over to the what we want to show thing, and it elaborates on this condition, elaborates on this condition only, I should say. Elaborates on that guy. Okay? And what does the order of phi of a mean? And in particular, it kind of investigates what it would mean for the order of phi of a to divide n. So remember, if the order of phi of a divides n, then that means that phi of a to the power of n has to end up at the identity. Okay? And in particular, those two things are equivalent statements. Okay? So the order of a, or order of phi of a, I should say, the order of phi of a equaling or dividing n is the same thing as what we set out to prove here. Okay, so basically I'm trying to show that I'm trying to do my what to show first instead of elaborating on my no condition. And this is just kind of a reorganization of that bridge idea. Okay, so I elaborate first on what a definition means. So what something to the power of n means. And then in the next line here, I'm using what it means to be a homomorphism. Now, in the next line, I didn't really say why I did that. Perhaps I should. Just to remind the reader that a to the power of n is equal to e because the order of a is equal to n. And then homomorphisms send identity to identities, so I get the last line. And I also explain why that happens. So always having the little reminders after lines is good, and this is sufficient formality for me. In some cases, you might have like a paragraph that either follows or precedes the proof that says these things in complete sentences, but I actually find that more confusing than just putting it clearly here, as long as it's not really stuffed into the margin or something. And then we kind of make a sentence here that says what we showed related to the orders. And then we can always have a therefore statement connecting our know and show. Okay, so therefore, if the order of A is equal to n, then phi of A divides the order of A if phi of A is, or maybe I should say, I kind of like the phrasing, as long as phi of A is a homomorphism. Actually, the sentence structure that I would prefer is to say, therefore, if phi is a homomorphism, then this happens. But lots of ways to phrase that last sentence. Okay, so this is how I would write up a proof like this, and a little bit of notes on how you might see it written versus how it was done originally.